We'll have a quick look at question 2 from the Chief Mate's Stability paper from December 2023, and it's a bilging problem. We're given the dimensions and we're asked to calculate a final draft and a change in GM. Notice they've asked for the change in GM because you haven't been given your kg. Of course kg is constant anyway, but we don't need it to work out the change in GM. Now I would always recommend that you do a sketch. So I've set out the sketch there with the values, and because we've got permeability, what I do now, I multiply that of course to get the effective length. Once you've done that, cross out the 18 and only use the 11.7 throughout the problem. As soon as you've converted, forget the 18. Okay, and don't forget to check the link at the top of the page there for my website. So working out the effective length, we then use that to work out the sinkage, and that gives us our final draft. Now working out the change in GM, as I say, we don't have the kg, but we can use the change in km because the kg is constant. We know that km is kb plus bm, but looking at the sketch, definitely our water plane area is intact. Nothing is affecting the water plane area because we've been bilged below the flat. Therefore the bm remains the same. So the only thing that will change will be the kb. So effectively the change in kb is the change in GM. So what we also need to do here, after we've worked out the initial kb, simply draft divided by 2, we must use the volume and moments to work out the final kb, because geometrically we can't push two ends together to form a geometric block because we've got this bilged area here. So whenever you have a bilging problem where you've got a watertight flat, inevitably you're going to have to do a volume and moments table. So my calculations, I get a change in GM of 0.095, and it's actually an increase in GM as well.